This map shows the places where we draw water from the River Thames for consumption, and where we discharge our waste into it. Notice is that waste is discharged, mixed with the natural flow, treated for consumption, and then discharged again several times. This results in a dual system that complicates traditional hydrological modeling. If we add other factors such as treatment management, groundwater dynamics, land use, and other processes, we can see how quickly the complexity grows. How can we possibly predict the behavior of such a complex system if we keep using traditional, separate, siloed models, one for each process? The answer is quite simple: we just cannot do it. We need a model that coordinates these processes into a unified system, striking a balance between model integration, resolution, and process specificity. We call this model the Water Systems Integrated Model, or Wsimod. The ideas of water systems integration we propose are explicitly referenced in the latest report by the Independent Water Commission as a preferred evidence-based approach to planning. Our model is also part of the National Infrastructure Modelling Service, with the aim of putting to work the UK's modelling capabilities. Wsimod is a framework that has a core functionality of water systems dynamics, which can accept many submodels that represent important dynamics we want to study. Our team has tried and validated a large number of these processes, and we are constantly working to improve and add other layers. We have designed a method of plugging these other functionalities into the model and between each other, so that they get orchestrated to produce our estimates on water quality, quantity, storage volumes, and concentration of various pollutants over time. Our method allows us to keep track of the effects and interrelationships of these dynamics as they are processed inside the model, as well as their direct relation to the physical world for data for validation. Wsimod can be used more traditionally as an impact assessment tool, where we evaluate the effects of a given project or proposal on the water system. We can also use it as source tracking, where we can identify the sources of pollution or water abstraction at a given point. Finally, it can be used as an optimization tool, where the algorithm generates the most suitable proposal for a given policy objective. Wsimod has been extensively validated over several years of research and development and academic work. This work has been supported by partnerships with a large group of private and governmental organizations in the UK. Wsimod comes in two main formats: the full model, which is open source and freely available on GitHub, as well as the forthcoming Wsimod UK. The GitHub repository allows users to download the model and deploy it to their project in a fully customized, DIY manner. It includes the latest features of research carried out on various related processes, such as groundwater and others. Wsimod UK will work as a web-based service, where the user selects an area of the UK for analysis. The service shall automate the process of data gathering, pre-processing, and basic calibration that would otherwise have to be done by the user. It will then send a file for Wsimod installation and running locally. Wsimod can be learnt independently using the online manual and tutorials. We also offer training sessions for organizations on its use and data interpretation. Come and join us and contribute to Wsimod repository.